Hey everyone. Today, we're going to dive into this really awesome shortcut in trigonometry. It's going to let you solve some super tricky problems. And the best part? You won't even need a calculator. Let's jump right in.
All right, so picture this. You're sitting in math class, you're staring at a problem, and it just feels impossible. We've all been there, right? Well, today, you're going to learn the secret to totally cracking that puzzle.
So here's the mission, should you choose to accept it. How do you find the exact value of the sine of 75 degrees? And when I say exact, I mean exact. No calculators, no messy decimals. We're talking a nice, clean answer, with fractions and square roots.
Okay, so you've probably got those superstar angles memorized, right? 30, 45, 60 degrees. They're the ones we see all the time. But 75 degrees? That one's not on the usual list. So what now?
Well, guess what? It turns out there are these sort of secret keys, these amazing formulas that can unlock problems just like this. They're super powerful, and they let us turn a really hard angle into an easy one. And the main trick here, it's actually super simple, which is what makes it so brilliant. You just take that difficult angle, like our 75 degrees, and you break it down. You express it as a sum or a difference of two easy angles that you already know. It's kind of like breaking a giant, scary task into two small, totally manageable steps. So let's look at our first tool. This is the sine identity. This thing lets us figure out the sine of two angles, A and B, added or subtracted together. And look closely. The sign in the middle, the plus or minus, it stays the same on both sides of the equation. That's a key detail. All right, next up, the cosine identity. Now, you got to pay attention to this one because it tries to trick you. See the signs? If you're adding A and B inside the cosine, you actually subtract on the other side. And if you're subtracting, you add. It's the total opposite. This is a classic spot where people mess up, so definitely keep your eye on that. And to round out our toolkit, we've got the tangent identity. Yeah, it looks like a big fraction, but the logic for the signs is pretty similar. The sign on top matches what you're doing, plus for plus, minus for minus, but the sign on the bottom, it's the opposite. So there you have it. These three formulas are everything we need to solve this thing. Okay, that's enough theory. It's time to see these things in action. Let's put these formulas to the test and actually solve a problem. So let's go back to our original puzzle, sine of 75 degrees. First step, we break it down. 75 is just 45 plus 30, right? Easy enough. Now, step 2, we plug that into our sine formula. That gives us sine of 45 cos 30 plus cos 45 sine 30. For step 3, we just substitute in the values we already know. Sine of 45 is root 2 over 2, cos 30 is root 3 over 2, and so on. We do a little bit of multiplication, a little bit of addition, and there it is, step 4, our answer. The square root of 6 plus the square root of 2, all divided by 4. And we did it all without a calculator. How cool is that? Okay, let's try another one. What about the cosine of 15 degrees? Well, we can write 15 as 45 minus 30. So we use our cosine formula, and remember that tricky sign flip? Since we're subtracting the angles, we're going to add in the formula. We plug in our values just like before, and we get our final answer. Whoa, hang on a second. Take a look at that. The answer for sine of 75 is the exact same as the answer for cosine of 15. That is not a coincidence, folks. This is actually a super cool thing in trig called a cofunction identity. See, 75 plus 15 is 90. It's all connected. Pretty neat, right? All right, let's do one more, just to make sure we've got this down. Let's tackle the tangent of 75 degrees. Same first step, we break it down into 45 plus 30. We plug the known values for tan 45 and tan 30 into that fraction formula. Now this one does need a little extra algebra at the end to clean it up. You got to multiply by something called the conjugate, but the process is basically the same, and it spits out this really clean, simple answer. 2 plus the square root of 3. So you might be thinking, okay, that's a neat little trick, but it's so much more than that. This shortcut is actually incredibly powerful, and it has some huge benefits. I mean, think about it. You can now find the precise value for tons of new angles. You don't need a calculator, which is a game changer on a test. You also don't have to memorize a giant list of values anymore, just a few key ones. And this isn't just some random thing for your trig class. This is a tool you'll actually use later on in calculus and physics. And honestly, it just builds your confidence, right?
It shows you that you can take something that looks really complex and break it down into simple, solvable pieces.
So really, what you've just picked up isn't just another technique. It's a whole new way of looking at these problems. It's kind of like you just unlocked a new math superpower. And if there's one thing to remember from all of this, it's this idea right here. Any difficult angle can be expressed as a sum or difference of easy ones. That's it. That's the secret. It's a huge problem-solving principle, and here we're just applying it to trig. So now, you can solve for any angle that's built from these simple parts. Think about it. 105 degrees, that's just 60 plus 45. What about 165? That's 120 plus 45. They're all within your grasp now, and you don't need a calculator for any of them.
So, I'm going to leave you with a question to chew on. Now that you have this new skill, this new superpower, what impossible angle are you going to solve next? Go on, give it a try. Thanks for watching.